Hello. So I wanted to go into a little bit more in depth about the framework of the AI in my game. So this Sword Lord 2, the environment is going to be, it's going to be a more a traditional level. It's not going to be Sword Lord 1 where it was just a single arena, circular arena with, not really any obstacles besides the wall. And this will help me, have fun designing a level, putting pits and secret areas and more traditional structures, houses and open areas as well as closed, arenas. So so I kind of wrote stuff down to go over and a list of stuff. So if I sound like I'm reading, forgive me. So let me create an AI. Okay, here we go. So with Sword Lord 2, I wanted the enemies to be able to move around this level, move around the world without, having to run into a wall, bump into it, and walk a correction distance and then try to... That's really clumsy, especially in a world that's a little bit more realized. I can't have that. So the AI needs to be able to get to any position in the world within reason. So how I'm doing it in Sword Lord 2 is it's very similar to Sword Lord 1 in that AIs are actually two objects working together in the same position but doing different things. So in Sword Lord 1, there was one entity that just handled, that was literally a collision physics box, physics circle, and the second entity was a kind of character model. It was passable, it didn't have collision on it, but it played animation, it held the held the sword and weapons and everything. So that's what I'm doing in Sword Lord number 2. So if you see here, there's a little like green egg thing, and this is the pathfinding. This is the pathfinding part of the AI. And the reason why I'm separating these two, every AI into two, is so that it's easier to manage two different aspects of an AI. Pathfinding is definitely AI, but I don't want it to be part of the main AI loop, if that makes any sense. I want the AI to worry about one part of the AI to worry about just attacking if it's within distance to its target, handling animation, handling blending, handling decision making. That's one entity that I want to have its own little thing, and the pathfinding entity is doing its own thing. So the pathfinding entity I'm going to call the Pathfinder, and the other entity is called the decider or the decision entity. Saying entity is really hard. So as you can see right now, if I switch the modes, it just will hide one and show the other. This is the Pathfinder. Now this is the character model. This character model is actually pretty nothing right now. It just assumes the position of the Pathfinder. So the character model was not really implemented yet, but it's the groundwork is there. It's a separate entity, but it's following the position. So when you have two entities that are together or working together to become one, it helps to give them ways to give information to each other, only the relevant information, because if you're sending too much between them, it's going to be hard to keep track of. So what I wanted to do was just have the Pathfinder only just worry about getting to a spot that I click. So this yellow box, that's the 3D position in the world that I wanted to get to. And this is only a position, it's an XYZ vector in Game Studio. it handles getting to this position. It will handle jumping. I manually was able to get him to jump. It handles jumping, and it handles bumping into other AI. So the decision-making entity, which is going to be this guy, if he sees an enemy, he's going to want to get to that enemy, and that's it. All he needs is the enemy position, his vector, the enemy's vector, the enemy's position. But when it comes to the Pathfinder, he needs to be able to do two things, and it's kind of important. Excuse me. So the two things, the two types of movement he needs to do is the A-star pathfinding and the straight line movement, which is if he sees this end position and he has a good walkable line of sight to it, he will break out of his path and move to that position. But the AI itself, he's never going to want to actually decide, oh, which should I do? Should I do pathfinding or should I do straight line movement? I don't want to put that in his decision loop. All I want the AI to do is have a vector to move to, and that's it. That's where he wants to go. And the Pathfinder will do the rest of the work. So this is actually, it sounds easy when you do implement a pathfinding solution, A-star, Dijkstra or whatever, and you actually get it working in the game. It's such a different thing to actually get it to work with, with straight line movement. So here's what happens. I'm going to click here. The entity has a clear walkable line of sight. He won't do pathfinding. Right? You see it? He's walking straight to it. He's not moving to any nodes. The nodes are highlighted in white. Okay. But if I move his target position over here, where the mouse is now, he's not going to have line of sight. So what is he going to do? He's going to do pathfinding first until he gets line of sight, and then he'll move straight. So watch. I'm going to slow it down. I click there, see these lines? He's pathfinding now. He's going to the boxes. Speed it up. He's going to move to this target node. Oh, but you see, now he switched to straight line. He didn't go to this node because he saw he can have a safe walkable position to that straight line. I mean to the vector. So with just this 3D position, the AI can only, the decision-making part of the AI will only need to handle the 3D position while the Pathfinder figures out a way to get there. So I'm going to put him up here. The AI will pathfind. And the second he has a straight line, he'll move to it. No need to worry. Here he is moving again. So now I'm going to click here, and there he goes. Let's do it again. See, he's pathfinding, but the second he gets line of sight, or he gets a decent position, he will move straight and break out of the path. And this was that entity I showed you before. Okay. So there's so many edge cases that will happen. If you see these two nodes, this 1, 2, they have line of sight with each other, but they also have this wall between them. So if an entity, if you're building a level and you put this between them, if you don't implement jumping, an entity will see that this, hey, I can pathfind my way there using the nodes, but the second I try to move to the other node, I'm hitting this wall. So what you have to do is you have to implement the vaulting behavior, which you've seen before. And you have a vault up and get up. But you see, this vaulting behavior, the jumping, this is not part of the AI, quote unquote. It's just part of the Pathfinder, which literally just, he needs to get a path, the pathfinding entity. So what I like about this system is that, well, I don't know why I call it system, but currently what it is now, the AI will only need to, the decision-making AI will only need to know where it wants to be, and the Pathfinder will do its best to get there. So if an AI is walking around doing his patrol, and he hears a sound, he will move to that sound, and that's it. He'll just, all he needs to do is get a position in his mind, and the Pathfinder will move for him. So we covered the A-star pathfinding. Now we'll go over some entity to entity avoidance, or just shoving. So when you have these two, I'm going to have two AR3, and see how their yellow positions are here. If I click here, they're all moving to this position, and they all actually are shoving each other. They're kind of dancing. But I kind of don't mind this behavior, because not every entity will be moving to the same exact spot in a real game scenario. But look, they're all pushing each other, and you won't really tell now, but these entities, they're actually not touching each other. They're literally just moving away from each other preemptively before they even get to collision. And this actually helps a lot. If AI or any two objects collide with each other, the game and you want them to, make sure they don't get stuck, the game will do gliding operations where a collision will happen, then the game will move them farther away and get them to move back together to try to get them in a resting place. And that's where the sliding behavior comes in normal, I guess, game development. But here, what happens, the bad thing about it is, if two objects are constantly hitting each other, that's a collision that needs to be solved. And it needs to be solved within that frame, or as fast as it can. And if you have too many entities bumping into each other, triggering the collisions, it will slow the game down by a lot. So this behavior here, it looks a little funny, but it's actually very good, because if you can see these little white lines, they're all hitting each other and they're moving away from each other. And because of this, a lot of their movement will actually be relatively liquidy, if that makes any sense. Because they all serve all fit their little place. And they're all pushing at each other. But I like this behavior because the frame rate is, at least in this windowed position, it's 300 to 400. And watch what happens as they move. They line up they move like a swarm, kind of. And they don't hit each other. They're not actually hitting each other. See that kind of honeycomb behavior.